This is your video for section 10.1, and we're going to talk about the language of hypothesis testing. The objectives in this section are 1. Explain the concept of hypothesis testing. 2. Explain the steps of a hypothesis test. 3. Determine the null and alternative hypotheses. And 4. Explain type 1 and type 2 errors. Objective 1 is to explain the concept of hypothesis testing. So to start this out, I'm going to tell you a story. This is a story about a jury. Our class has been selected to serve on a jury in a criminal trial. As jury members, we must start with the assumption of innocence, because the defendant is assumed innocent unless proven guilty. Remember that guilt must be proved beyond a reasonable doubt. We can only reject the assumption of innocence if the evidence of guilt is extremely strong. Avoid the mistake of convicting an innocent person. In our justice system, this mistake is considered much more serious than the mistake of acquitting someone who is guilty. If we think about that last statement, convicting an innocent person is the same as rejecting the assumption of innocence when the defendant actually is innocent. We want the probability of making this mistake to be very small. So here's our class, listening to all the evidence, all the testimony. How are we going to determine what verdict to give? If we could find some way of coming up with a numerical measure of the evidence, that would really help. From what we know of statistics, we could take that numerical measure of the evidence and find the relative position for that in some probability distribution. So we could find a percentile or a z-score or something that would tell us the relative position of that measure of our evidence. Once we knew that relative position, then we could measure the probability that the defendant is actually innocent, given the strength of that evidence. So here's our evidence that we're starting with. If our evidence is not very strong, that means the probability of innocence is not small. It might not be large, but on the other hand, it's not small. That would lead us to a verdict of not guilty. Another way of thinking of a verdict of not guilty is that we do not reject the assumption of innocence. On the other hand, if our evidence is very strong, that means the probability of innocence is very small. This would lead us to a verdict of guilty. And another way of thinking of a guilty verdict is that we're rejecting the assumption of innocence. On this side of the decision-making tree, if our evidence is extremely strong, then the probability that the defendant is actually innocent is very small. And this is the one that we want to be very small, because we don't want to be convicting an innocent person. Let's leave our story for a little bit and talk about the elements of a hypothesis test. So this is terminology and notation translated into plain English as much as possible. So when we're doing a hypothesis test, we have something that was our original claim. The goal of research or study is to determine whether this claim is likely to be true. Now, our alternative, or what we sometimes call our research hypothesis, the notation for this is H with a subscript 1. This represents the original claim. What we call our null hypothesis is H sub naught. This represents the status quo. Our significance level, which we call alpha, this is the probability of a type 1 error, which would be rejecting the null hypothesis when the null hypothesis is actually the true one. A test statistic is a measure of the relative position of the sample statistic. So a sample mean, a sample proportion, something like that, using a probability distribution. A p-value is a value that's based on the test statistic. It's the probability of the test statistic being at least that far out in the tail of the distribution. The initial conclusion is based on a comparison of alpha, the significance level, and the p-value. And our initial conclusion always has to do with the null hypothesis. We either say reject the null hypothesis or do not reject the null hypothesis. Our final conclusion is a statement of the results of the test in terms of the original claim. In other words, this is a statement in English saying that either the evidence is sufficient to support the claim or it's not sufficient. Now, how is hypothesis testing related to our jury story? In hypothesis testing, we have an original claim, which translates into an alternative hypothesis. In our jury story, this would relate to the claim that the defendant committed the crime. In a hypothesis test, we have the null hypothesis, which represents the status quo. In our jury story, this would be the assumption that the defendant is innocent. That's the assumption that we're starting with, and we can't reject that assumption unless we have very strong evidence. Now we have our significance level alpha, which is the probability of rejecting the null hypothesis when the null hypothesis is true. This would be like the probability of convicting an innocent person. So it's the same as the probability of rejecting the assumption of innocence when innocence is actually the true status. Our test statistic in our jury story would be the measure of the strength of the evidence, whatever measure we could come up with. The p-value relates to the probability that the defendant is innocent given the strength of the evidence. The initial conclusion in our jury story would be our decision to reject or not reject the assumption of innocence. And the final conclusion would be related to our actual verdict, guilty or not guilty. In other words, on our jury, we're saying either yes, there's enough evidence for us to conclude that the defendant is guilty, or no, there's not strong enough evidence to conclude that the defendant is guilty. Objective 2 in this section is to explain the steps of a hypothesis test. So step 1 is to determine the null and alternative hypotheses. Step 2 is to choose the level of significance, alpha. Step 3 is to compute the test statistic. Step 4 is to find the p-value and determine the initial conclusion. And step 5 is to state the final conclusion. And these steps are the same no matter what type of hypothesis test we're doing. Objective 3 is to determine the null and alternative hypotheses, because this is where we have to start with any hypothesis test. So in order to do a hypothesis test, we first have to have a claim or a statement that's being made. So the first step in finding the null and alternative hypotheses is to write down this claim as a complete sentence. Then we're going to take that claim or statement and translate it into an alternative hypothesis by answering these questions. The first question is, what parameter is being tested? In this chapter, it's either going to be a mean, which we represent with mu, or a proportion, which we represent with p. Next question is, what inequality should be used? For our alternative hypothesis, it has to be either less than, greater than, or not equal to. There cannot be an equal in any of these three. And finally, what's the value of the parameter stated in the claim? The value used in our hypotheses never comes from the sample data. It always comes from the claim. Once we've answered those three questions, then we can translate the answers to those into our alternative hypothesis, H1, in symbols. Once we have the alternative hypothesis, then we can write the null hypothesis just by replacing the inequality in our alternative hypothesis with an equal sign. Let's look at some examples. So for the given claim, determine the null and alternative hypotheses. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher claims that the mean length of a call has increased since then. First, we're going to write the claim as a complete sentence. The mean length of a call has increased since March 2006, when it was found to be 3.25 minutes. It's important when you're writing out the claim to include the value of the parameter that's listed in the claim. That's something that you need to know. Now we're going to take this claim and translate it into symbols for our alternative hypothesis. So the first question is, what parameter is being tested? And here, since we're talking about a mean, the parameter we're testing is the mean, mu. What inequality should be used? When the claim is saying that the mean length of a call has increased translates to a greater than. And finally, what's the value of the parameter in the claim? It's 3.25 minutes. So we can take those three things and translate it into our alternative hypothesis, and that is H1, and we always write our hypotheses this way, either H1 or H0, and then a colon, and then we have the mathematical symbols after that. So our parameter is mu, our inequality is greater than, and the value of the parameter in the claim was 3.25. So there's our alternative hypothesis. Our null hypothesis uses the same symbol and the same number. We just replace the inequality with an equal sign. So to say these in English, our alternative hypothesis is that the mean is greater than 3.25. Our null hypothesis is that the mean is equal to 3.25. Here's another example. In 2008, 62% of American adults regularly volunteered their time for charity work. The politician claims that this percentage is different today. So first, again, we'll write our claim as a complete sentence. That is, the percentage of Americans who regularly volunteer their time for charity work is different than 62%. Again, it's important to write enough in this claim so that you know what we were talking about in the beginning. So you need to include what our percentage is measuring in this case, and that is the percentage of Americans who regularly volunteer their time for charity work, because we'll use this information later on in our hypothesis test. You also need to include wording that will allow you to talk about a proportion or a mean, and you need to include the value that's listed in the claim. Now we're going to translate this into our alternative hypothesis. So first, what parameter are we testing? Since we're talking about a percentage, that's the same as a proportion, and the notation we use for that is p. What inequality should be used? Different translates to a not equal to. And what's the value of the parameter in the claim? 62%. We're going to convert this to decimal, so we'll have 0.62. So our alternative hypothesis will be H1 is that P is not equal to 0.62. To get our null hypothesis, we just replace that not equal to with an equal to. So our alternative hypothesis is that P is not equal to 0.62. Our null hypothesis is that P is equal to 0.62. Here's a third example. The Federal Aviation Administration claims that the average weight of an airline passenger, including carry-on baggage, is less than 195 pounds. So we want to write this claim as a complete sentence. That is, the average weight of an airline passenger, including carry-on baggage, is less than 195 pounds. Translate this into our alternative hypothesis. What parameter are we testing? Remember that average is another word for mean, so we're testing the mean, which is mu. What inequality should we use? Less than translates to less than, and the value of the parameter in the claim is 195 pounds. So our alternative hypothesis is that H1 is mu is less than 195. Or in other words, our mean is less than 195. Our null hypothesis is that the mean is equal to 195. The last objective in this section is to explain type 1 and type 2 errors. So to do this, let's go back to our jury story and think about the outcomes of our trial in terms of the actual truth versus the verdict that we come up with. There are actually 4 different possibilities for the combinations of these two. So here's our truth here and our 2 possible verdicts over here. So if the truth is that the defendant is not guilty and we come up with a verdict of not guilty, then we have the correct verdict. If the truth is that they're not guilty and we come up with a guilty verdict, then we have an incorrect verdict, and this is the most serious type of error. This would mean that we're convicting someone who's actually innocent. So this is the one that we want to avoid most of all. Now, if the defendant actually is guilty and we find them not guilty, then we have an incorrect verdict. And again, this error is not considered as serious as this one up here. Finally, if they are guilty and we find them guilty, then we have a correct verdict. Now, how does this relate to hypothesis test results? Well, here, instead of truth versus a verdict, we have the truth, or the true value of the population parameter, versus our test conclusion. There are 2 possibilities for the truth. Either the null hypothesis is true, or the alternative hypothesis is true. And we have 2 possible test conclusions, either do not reject the null hypothesis, or to reject the null hypothesis. So this would be like not guilty and guilty. So if the null hypothesis is true and our conclusion is do not reject the null hypothesis, then we came to the correct conclusion with our test. If the null hypothesis is true, but our conclusion is to reject it, then we have an incorrect conclusion, and this is a type 1 error. And this is the most serious type of error. This is the one that we really want to avoid. Just like we would want to avoid on our jury convicting someone who's innocent. Now, if our alternative hypothesis is actually true, then if we have the conclusion that we don't reject the null hypothesis, that's an incorrect conclusion, and that's called a type 2 error. This error is not considered nearly as serious as a type 1 error. Finally, if our alternative hypothesis is true and our conclusion is to reject the null hypothesis, then we have come to the correct conclusion. So when we're designing a study and determining what we want our significance level to be, our significance level is going to depend on the consequences of a type 1 error and how serious those consequences are. For example, if we're doing some type of drug testing where the consequences of this type of incorrect conclusion could be very serious, could be a serious safety risk or something like that, then we want the probability of making this error to be extremely small. So we would make our significance level very small, like maybe 1% or even less than that. Sometimes it's more like 0.1%. On the other hand, if we're doing research and collecting sample data just for information purposes, then the consequences of making this type of error would not be as serious. So in that case, we could afford to make our significance level a little larger. In some cases, we might go as high as 10% with our significance level. So the significance level alpha is the probability of a type 1 error. Alpha should be determined during the design stage of a study before we collect the sample data. And to determine alpha, we consider how serious the consequences of a type 1 error would be. The more serious the consequences, the smaller our value of alpha should be. And some typical values for alpha are 10%, 5%, and 1%. Let's do some examples of identifying type 1 and type 2 errors. So back to our study on the length of cell phone calls. We already found our alternative and null hypothesis. Now let's use those to identify type 1 and type 2 errors. So a type 1 error is rejecting the null hypothesis when the null hypothesis is actually true. In this case, that would mean concluding that the mean length of a call is greater than 3.25 minutes when it really isn't. Because again, if we're rejecting the null hypothesis here, that means basically that we're accepting the alternative hypothesis as the truth. A type 2 error means failing to reject the null hypothesis when the alternative hypothesis is actually true. Here, since our alternative hypothesis is the mean is greater than 3.25, that would mean that that was actually the true case, but in our testing that we didn't have strong enough evidence for us to reject the null hypothesis, so we accept the null hypothesis as the truth. So a type 2 error here would be concluding that the mean length of a call is not greater than 3.25 minutes when it really is. Here's another example, and this is from the example about adults who volunteer for charity work. We came up with our two hypotheses. So again, type 1 error is rejecting the null hypothesis when the null hypothesis is true. This would mean concluding that the true percentage of Americans who volunteer for charity work is different than 62% when it really isn't. So again, it's like accepting the alternative hypothesis when the null hypothesis is the true one. Type 2 is the opposite. This would be accepting the null hypothesis when the alternative hypothesis is actually true. And that would mean concluding that the true percentage is not different than 62% when it really is different than 62%. Okay, and finally, our problem about the weight of an airline passenger. In this one, our null hypothesis was that the mean weight is equal to 195. Our alternative was that the mean weight is less than 195 pounds. So type 1 would mean rejecting the null hypothesis when the null hypothesis is true. So in other words, this would be like accepting the alternative hypothesis that the mean weight is less than 195 pounds when that's not actually the truth. So in other words, concluding that the mean weight of an airline passenger is less than 195 pounds when it really isn't. And again, if you think about the consequences of this test conclusion, this could be serious. When we're talking about weights for airline passengers, that might determine the capacity that's allowed on the plane. If we conclude that the mean weight is less than what it really is, we could end up with too many passengers for the plane to safely carry. A type 2 error would be failing to reject the null hypothesis when the alternative hypothesis is true. In this case, that would be saying that the weight of an airline passenger is not less than 195 pounds when it really is.